In this video, we'll learn about how to distinguish between linear and nonlinear relations. So very often we'll get a set of data where when we plot the points, we can tell right away that the data are not going to all fit on one single line. In fact, sometimes the data might not even represent a function. But when we plot the points in a case like this, even though these data points don't all fit on one single line, we can still tell that there's a general linear trend. If I were to draw a line that looked something like this, something that goes kind of through the middle of the data points, then not all of the data points are on that line, but all of the data points are near that line. And so if I wanted to make some predictions about what this data might do outside of the points that I was given, for example, if I were gathering sales data from a company and I wanted to try to predict that data in the future, then I might use that green line that I just drew as a way to model and make predictions about what that data might look like. Here's another example. This data also has a general linear shape. And again, the line that I might draw would look something like this. This one has a negative slope, whereas the previous one had a positive slope. So again, we're not looking for a line that goes through all of the points. That's impossible in this case. All we're looking for is a line that does a good job of coming close to all of the points. But not all data sets are going to be able to be fit well by a linear function. So for example, this data set would not be a good example of a linear relationship. If we try to draw a line, we might draw a line something like this, and that does a good job of going through the first half of the data points, but it doesn't do a very good job of going through the second half of the data points. Similarly, we could draw a line that looks something like this, and that would do a good job of modeling the second half of the data, but not the first half of the data. In this example, once again, no single line is going to do a very good job of fitting through all of these data points. We might do a good job of trying to model the first chunk, and maybe this stuff in the middle, and then maybe these points at the end, but no one single line is going to work. So again, this is a nonlinear relationship. This one is sort of a borderline case. Again, we could do a fairly decent job of modeling the first chunk of data with this line, but once we get towards the end of our data set, these data points at the end are not well modeled by that line. So once again, we have a nonlinear relationship. So generally what you want to do if you want to tell whether a data set is linear or nonlinear is you want to plot the points and then just look at it and see if a single line would do a good job of getting close to all of the points in the data set.